Guys, Miss Smith here. I'm getting ready to talk about Module 4 of 3rd grade Eureka Math, and this is Topic C quiz, which deals with finding area and breaking apart larger area rectangles into smaller pieces. Our first question, number 1, says which rectangle has the same area as rectangle with side lengths of 3 inches by 4 inches. So we're going to start by we have to discover what is the area if I had a 3 by 4 inch rectangle. So I've got a side that's 3 inches, I've got a side that's 4 inches. And one of the big things that we've been moving toward is instead of having to tile and count all, we can use multiplication and we can multiply the length times the width. So 4 times 3, or 3 times 4, and that would give us an area of that rectangle for 12 square inches because we tile in with square units, and these happen to be inch tiles. So the area of the rectangle they're wanting me to find is 12 square inches. That's the first thing I have to know. Then I'm going to look at my choices. I have choice A, which is a 5 by 4. 5 times 4 would give me 20 square inch rectangle. Choice B is a 6 by 2. That would also be 12 square inches. So that is the same as this one. We have a 12 square inch and a 12 square inch. Even though they are configured in different arrangements, they both have the same area of 12 square inches. Okay. Question number 2. Can each expression be used to find the area of the rectangle? We have to circle yes or no. Here is our rectangle, and each of those tiles or squares represents 1 square unit. We're going to go ahead and talk about what are they doing by shading in part of this. This has been the big idea for this particular topic. So when I have a rectangle, I'm going to multiply the side by the other side. So length times width. And in this case, if I look at the entire width of this rectangle, it is 12 units. Now, most students don't know their 12 facts yet, of 4 times 12. So because that might be difficult for them to find out, we instead break it apart into this 4 times 10. And then if we look at this white section over here, it would be a 4 times 2. And that is an area for one part, and then an area for a smaller part. But in order to find the total area, I then have to put those two pieces together. So if you look at the middle choice, it says 4 times 10, which was this first area we just looked at. And it says 4 times 2, which is this area that we just looked at. And then it shows that they are putting it together with that plus symbol right there. So yes, this middle choice would absolutely be a choice. Now, when I think about what is that area, we said 4 times 10, that would be 40 square units. And then we said 4 times 2, that would be 8 square units. And I put those two together to give me 48 square units. So going forward, we know that this choice was correct, and we know that the total of this rectangle, the area is 48 square units. I about said inches, but it's units. So I'm going to look at some of my other choices. Now, when I look at this last choice, it is just having me multiply as I go across. So if I start here and say 2 times 10, I would have 20. And if I continue to multiply that, 20 times 4, if I know 2 times 4 is 8, then 20 times 4 is 80. So thinking about 80 square units versus 48 square units, those would not be the same. So this would not be the same square units. My last one we're going to look at is just showing it a different way. Remembering that when I find area, I multiply my length times my width. And in this case, they broke apart the width into 10 plus 2. So when I look at this equation, I have a side that is 4, and I am multiplying it by a side that is 10 plus 2. So yes, this also matches. All right, on to question 3. This question is in 2 parts, and the first introduces, it says James wants to find the area of this rectangle. The rectangle happens to be 15 units by 3 units. So when I look at part A, I have a rectangle that is 15 units across and 3 units down. It's part A then says James uses the expression 10 times 3 plus 5 times 3 to find the area of the rectangle. Then it says shade the rectangle to show his strategy. Shade the rectangle. His strategy was to break apart the longer side that was 15 into a part that is 10 and a part that is 5. And he has to put those together. So they want us to shade in a part that is 10 or a part that is 5. So I am, for the sake of time, going to do 5. 1, 2, 3, 4, 5. I'm going to shade in a 5 by 3. And that leaves a 10 by 3 over here. So you see we've broken it apart into 2 pieces. Okay? I'm going to just re-put that on there after I scroll down. So we use that then after we've shaded. I've got 5 shaded in. I've got 10 not shaded in. And each of the shorter sides were 3. Oh, goodness, frustration station. I apologize. We want to multiply each of those. So looking down at this equation, here is the entire area, how I would find it, 15 times 3. But we broke it up into a 10 by 3, that was white, and a 5 by 3, that is blue now on mine. And then they just want me to do the math. If I have 10 times 3, that is 30. And if I have 5 times 3, that is 15. That is how many square units are in there. So I would have 5, 10, 15 if I counted all of those. I would have 10, 20, 30 if I counted all of those. Then we simply do what that symbol is telling us, that operation. Put those 2 parts back together, the areas. So I have 30 plus 15, which is 45. And that is the area of the entire rectangle. 15 times 3 is the same as or equal to a 45 square unit rectangle. Moving on. All right. On number 4, they give a scenario on one page, and then they actually ask us to do something with the scenario. I'm going to read this scenario, and then I'm going to quickly move to number 5, because really, we're just gaining information from this. It says, Liz tiles her patio. The shaded rectangle represents the part of the patio Liz has tiled so far. So if you look at that dark gray that is in boxes or tiles, That is what she has already tiled. The unshaded rectangle represents the part of the patio Liz needs to still tile. The length of Liz's patio is 12 feet, and each tile or each square represents one tile, which is 1 square foot. A lot of information, but don't worry, it is also in this picture. This is the exact same thing they just told us about Liz's patio, but now we're going to do something with it. Label the lengths and widths of the shaded and unshaded rectangles. Write one value from the given answer choices in each box. Values can be used more than once. So they're just telling you that as you label the length and the width here, these answer choices are going to be those numbers. It may be a couple of them, it may be 3 of them, but you can reuse these side lengths as well as needed. So let's start with the shorter side, this length here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I look and that is a choice. If this side is 9 feet, then I can come over here, and I know rectangles have parallel sides that are evenly lengthed, so I can also put 9 feet over there as well. So I have a 9 foot and a 9 foot on each of those sides, and I have used this choice. I look at the bottom, which they told me was 12 feet total. So the entire patio is 12 feet. But I noticed that they've only tiled a section, and there's a section left. I am thinking about this as I have 12 total feet, and I have broken it apart into something plus something. The tiled gray part is the first something. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The first shaded section is 10 feet. And then I have to think about 10 plus what would make 12? 10 plus 2 more feet would make 12. So that untiled part would be 2 more columns or 2 more sides of tiles in there. Okay, so we've got some dimensions. We're going to rewrite those really quickly before our time together runs out. We said we had a 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we had a 9. And we had a 10. And we had a 2. I have to then use those dimensions to fill in down here. Okay? I wish I could make this smaller. Let me see if I can. Oh, perfect. This will help us hopefully finish up before our time runs out. So again, 9, 10, 2, and 9. And then I'm going to use that to answer part B. What is the area of the patio she's already tiled? Well, the area she's already tiled is this dark gray. I'm going to circle it. That was a 9 foot by 10 foot. So to find area, I multiply length times width. So it was 90 square feet, that part. What is the area of the patio that still needs to be tiled? That's my white part right here. That was a 2 foot by 9 foot, which makes 18 square feet. And then what is the total area? I'm going to put together my 90 square feet with my 18 square feet to give me 108 square feet. I hope that that all makes sense. If you have any questions, feel free to reach out, and happy studying.